we talked a bit about, well, the language of mathematics, the algebra, the pronumerals and what have you. Now let's go and use them in these things we call equations. Basically the idea of equation is simply whatever it is we're trying to find, we want to make it the subject of the formula, for want of a better word. I mean, equations, formulas, they're basically the same thing. Let's start with a very, very simple equation. Not here to challenge you at all, but in fact, the first time you would have seen equations, probably back in primary school, they didn't put an X there, they might have put a box or something like that, and they'd say, oh, what number goes in the box? Essentially, you do an algebra there, without being called algebra. Now, there are different ways that people think about this sort of thing. A lot of people just simply say, oh, well, it's plus 3, so I'm going to subtract 3, and that'll sort of, yeah, okay. It's not how I think about it. I think about it as moving things, because I just want the pronumeral by itself, so I need to move everything else away. So that 3 I want to move to the other side of the equation symbol. But what I know is when it passes through the equation symbol, it changes its sign. And so I should end up with that. Now, of course, I don't necessarily write that down, but that is my thought process. I'm going to move this over here. That becomes 6 minus 3, so x is 3, and that's how I approach equations. Something like this, I want to get the z by itself, so I have to move through the equal symbol. Well, this time the multiplication becomes the division. See, it does the inverse operation. So when it moves through the equal sign, it does the inverse operation. The inverse of addition is subtraction. The inverse of multiplication is division. So, division. Again, don't necessarily write it like that, because we know 45 divided by 5 is 9. Mind you, writing it like that solves an interesting problem, because if it doesn't go in exactly, we're going to end up with a fraction. That, of course, is why the division symbol is what it is. Don't know whether you realise that or not. But a division symbol is a vinculum with a dot on the top and the dot on the bottom representing the two numbers. It's a fraction. That's what a division symbol is. 4 outside of a minus 5 equals 16. I have a choice. I could do the division first, pass it through the equal sign. I could expand out first. Which way did I do it? I expanded out first. Expanded out, I want to move that 20, or negative 20 in this case, through the equal sign. So I've added 20, 36. I now want to move the 4 through, so I divide it, I get 9. Then as we progressed, we made it a little bit trickier. There's pronumerals on both sides. Not a problem. We just got to move things. So I'm going to move the 2 that way. I'm going to move the z to the left. That's me. 2z is negative 11. Divide everything by 2. I leave it as an improper fraction myself. I think it's perfectly fine for an answer. Some people are obsessed, and they'll change that to 5.5. Why do extra work? You don't need to. Oh, pronumerals in the bottom of the fraction. And we know that we can't add these two together because the denominators need to be the same. So you could do that. You could do an algebraic fraction question and solve it that way. Or we could just get rid of the fraction by multiplying. But we multiply by that lowest common denominator. You know, if it's not there, put it down. So in this case, I'm going to multiply everything by 7y. And so we get 5 plus 14 is 21y. And we end up with 19 on 21. Okay. Special situation. Fraction equals fraction. Save a lot of time, you just cross multiply. So you imagine a cross going through the equal sign, and that's what you're multiplying together. So we have 3x plus 9, 10x minus 30 on the other side, and then we just play around with that. I probably moved, which way would I have done it? I reckon I would have moved the 3x to the right, so I end up with a positive number, and so then the 30 the other way. Interestingly, I've written the 7x on the other side because, of course, it's an equal sign. So even though I'm moving it to the right, I can still write it on the left because they're equal. So I can do it either way. 39 on 7. Okay, that was quick.